Welcome back everyone. I hope that you are excited to learn a new chapter. So in this chapter we will be focusing on probability distribution. For your information, probability can be divided into two. The first one is discrete probability while the second one is continuous probability. And continuous probability will be covered in the next chapter. So what is actually probability? Probability is actually the chance that something might happen. So when we talk about raining, right? So when you look at the cloud, it is very dark. So you can say that the probability of having rain perhaps 90% because you are almost sure that it will be raining. But if let's say you look at the sky, it is very clear. So you can say that the probability of having raining perhaps 0. Okay, so this chapter will explain to you or will discuss everything about probability distribution, specifically focus on discrete probability. I would love to show the overview of this chapter so that you can know in advance what will be covered in this chapter. So this chapter will be divided into four main points. The first one, we will talk about the probability distribution. So under probability distribution, we will discuss on the random variable. So you know that random variable can be divided into two, continuous and discrete random variable. So under these two, we will compute the mean, variance as well as standard deviation. Okay, the second one we will talk about binomial distribution. So under binomial distribution we also will compute the mean, variance as well as standard deviation, and we will also focus on the cumulative distribution. And the next one we will talk about hypergeometric distribution, and the last one is Poisson distribution. Okay, at the end of this chapter you are expected to achieve these 6 learning objectives. The first one, you should be able to identify the characteristics of the probability distribution, specifically focus on the discrete probability distribution. And you should also be able to distinguish between discrete and continuous random variable. So basically this is something familiar to you because we have covered this in the previous chapter, right? So this is very easy for everyone. And you are also should be able to compute the mean, variance and standard deviation of a discrete probability distribution. Although I know that everyone have learned about mean, about how to compute the variance and standard deviation, however the formula that you have learned before are actually different with this discrete probability distribution. And you should also be able to explain the assumptions of binomial distribution, the hypergeometric assumption as well as Poisson assumption, and should be able to apply all these distribution to compute their probabilities. Okay, what is a probability distribution? Probability distribution shows the possible outcomes of an experiment and the probability associated with this outcome. So let's look at the characteristics of your probability distribution. The first one, the probability of a particular outcomes is actually between 0 and 1 inclusive. What does it mean? So it means that whatever you compute, the outcome should lie within this number. You cannot have negative value, for instance negative 1. You cannot have a more than 1 value. For instance you get 2, 3, it is impossible because the value should only between 0 and 1. Remember that. The second characteristics of your probability distribution is that the outcomes are mutually exclusive. Well, what is exclusive? It means independent. For instance, if you toss a coin, so your outcome will have two. The first one, you may get head or actually tail, right? So you can get either head or tail. You cannot get something in between or both of them because when you toss a coin, you will get just one outcome. And if let's say I will give you another example, when we talk about gender, so you can have boy or girls. So you cannot have something in between. So you will get either one of it, right? And the last one, the list of outcomes is actually exhaustive. So what is this exhaustive? It means that the sums of the possibility of the outcome should give you 1 or equals to 1. For instance, you compute the first outcome, you get 0.01, and second outcome you may get 0.2, and the third one 0.4. Summations of all this will give you the value of 1. Okay? Suppose when you toss a coin, you are interested to get the outcomes of head showing face up. So in this case, you are tossing 3 times. So the possible outcome can range from 0 head, 1 head, you can also get 2 head and 3 heads. So let's look at the examples in this yellow table. So remember, you are tossing 3 times. So the first toss, you get tail. So you are very unhappy. The second toss, you get tail as well. You are interested to get head. And the third toss, you got tail. So what is the number of head here? So you get 0 head. So you can try second time. Maybe you will get 1 head, and the next time you will get 2 head and 3 head, right? So how can we want to compute the probability distribution? So when we talk about probability, so you have to write P refers to probability. So X refers to your number of head. So in this case, let's look at 0. The X is equals to 0 because the number of getting head is 0, right? So how to compute the probability? Probability, how many times do you see, can you see the 0? Okay, so you can see just one time over how many possible results? You have 8 possible results. So 1 over 8. So if you put it in the calculator, you will get the value of 0.125. So this is the probability of getting 0 head. Okay, so let's try with the probability of getting 1 head. So what is the value? So you have 1, 2, 3. So 3 out of 8 possible result. So what is the value? 0.375. So let's try with the probability of getting what? 2 head. So how many? 1, 2, 3. So 3 as well. So 3 over 8. So you will get 0.375. So that is how you want to compute the probability of getting something. Okay? We have explained on how to compute the probability distribution in the previous slide. So basically here you just want to present it in a table. So you call it probability distribution table. So remember, your interest is to get the number of head. So your head is your X. And the probability of outcome, probability of getting your X or getting your head. So if let's say you get the probability of getting 0 head. So 1 over 8, which is the total possible outcome. So you have computed, you will get 0.125. And just to let you know, summations of all these number, 0.125, 0.375, all of them will give you the value of 1. So what do you call this? This is one of the characteristics of probability distribution. We call it exhaustive. Summations of all the possible outcome or the probability of outcome will give you the value of 1. So if you want to plot it in a diagram, it will look like this. Okay, you may have a normal bell curve shape. Okay. Random variable. In any experiments of chance, the outcome, if let's say in the case of tossing a coin, you have head or tail, occurs randomly. So you don't know whether you will get head or tail. So it occurs randomly, right? And these are called as random variable. So let's take the other examples of random variable. The number of employees, or for instance the number of students absent in my class. I don't know whether there is no students absent in my class today, or maybe 1 student absent next week, and so on. So basically the outcomes are actually very random and I have no idea about it. Okay? Two types of random variable. So this is basically just a revision of what you have learned in the previous class. You know that random variable can be divided into two. You have discrete and continuous. Discrete random variable is actually the result of counting. So you can count 1%, 2%, 3%, and so on. And if let's say we talk about the previous examples of tossing a coin, so you can have what? 1 head, 2 head, 3 head, and so on. Remember, for discrete variable, you have a gap. So from 1, you jump into 2, from 2, you jump into 3, and so on. You don't have any decimal point for discrete variable. This is another example of discrete random variable. When we talk about the number of credit cards carried by customer. So some customer may not carry any credit card in their wallet. So the relative frequency of those who have no credit cards, perhaps 0.03. Well, some customer will carry one credit card, while other customers may carry 4 or more credit cards. So as I told you previously, summations of all these outcomes will give you the value of 1. So we call it exhaustive. Okay, this is just one characteristics of probability distribution. Continuous random variable. So you know that continuous random variable is the result of measuring. So you can measure your height, your weight, and so on. So because we are talking about continuous, so you assume that the number will keep continuing until forever. We can assume infinite number. Okay, so when we talk about continuous, you know that you have a decimal point. So if you look at the example, you have 4.67, you have 5.13, so the number has decimal point. Okay, this is just another revision of the continuous random variable. This slide shows the formula on how to compute mean and variance for your probability distribution. So as you know, mean is normally used to represent the central locations of your data. In other words, we use the mean to represent the central tendency or the center of your dataset. So in the case of probability distribution, the mean is also referred to as the expected value. So let me give you one example. If let's say in the question later on, it asks you to compute, or it asks you what is the expected number of students in my class. So basically that question asks you to compute the mean. Okay, another example, if let's say the question say what is the expected number of customer in a shopping mall. So when you can see these words expected, so they ask you to compute the mean using the probability distribution formula. So what is the formula? So summations of x. So when you talk about tossing a coin, so what is your x? Your x is the number of head. So x multiply with the probability of x. So we can say the formula is summations of x, or summations of your head, multiply with the probability of getting the head. So this is the formula for mean. Okay, so for the variance, you know that when you talk about spread or variation in your dataset, you will use variance formula or standard deviation. So what is the formula for variance for the probability distribution? So this is the formula, summations of x. So what is x? For instance, the number of head when you toss a coin, summations of x minus your mu. So what is this mu? Mu is this, your mean that you computed here. So summations of x minus your mean squared multiply with the probability of getting x, or getting your head. So this is the formula for variance. How about standard deviation? So standard deviation for the probability distribution is just the positive square root of your variance. It is very similar with the previous one. When you talk about the standard deviation, you just have to put the square root of the variance. Okay, so this is the formula for your standard deviation. Okay, so let's look at the examples on how to apply the formula for probability distribution when you want to compute the mean, variance, and so on. In this case, John sells new cars for this company. You call it Ford. John usually sells the most cars on Saturday. He has developed a probability distribution for the number of cars he expects to sell on Saturday. So basically, John has created this probability distribution table. So you can see here the number of cars sold, which is represented by X. So sometimes he has no car sold by him, and sometimes he can sell 4 cars. Okay, and he also has computed the probability of car sold, and you know that the totals of this probability will give you 1. You call it exhaustive. So this is one of the characteristics of probability distribution. So let's look at the question. The first question, what types of distribution is this? Okay, so for distribution you have to type. The first one you call it discrete, and the second one is continuous. When you talk about the number of cars sold, does it belong to discrete or does it belong to continuous? Okay, so you know that discrete is the result of counting. So you can count 1 car, 2 cars, 3 cars, and so on. So definitely the number of cars should belong to discrete. Second question, how many cars does John expect to sell on a typical Saturday? So when you look at this question, what is the key words? So this is the keyword expect. Okay, as I mentioned in the previous slide, when you have seen this word expect, it means that this question asks you to compute the mean. Okay, so what is the formula to compute the mean for the probability distribution? The mean is actually equals to summations of x multiplied with the probability of x. So let's compute it together. What is your first x? 0 multiplied with 0.1. So this is the first x. Plus, because we are talking about summation, second x, 1 multiplied with 0.2 plus second x, which is third x, 2 multiplied with 0.3 plus so on, right? And in total, you will get 2.1 as the mean. Okay, as simple as that. The third question, what is the variance? Okay, so this is second answer and this is the third answer. What is the formula for variance? Okay, so you have to refer to the previous slide. The formula for variance is summations of what? X minus your mu that you have computed squared multiplied with the probability of x. Okay, so how to compute it? So your x, what is your x? 0 minus 2.1 and then you have squared multiplied with the probability of the first x, which is 0.1. So put it as your first bracket. Okay, plus the second x. What is the second x? 1 minus 2.1 squared and then multiply with the second probability, which is 0.2. So this is your second bracket. Okay, plus and so on. So you should get the value of what? 1.29. So 1.29 is the value for your variance. So the easiest way to compute the variance is that just put everything in your calculator and let your calculator to compute it. Okay, normally I will put everything in this form so that it is easy for me to compute everything. Some students love to compute one by one, but the easiest way to save your time, just put everything in this form and compute it just one time. Okay. This slide will tell you how to compute your variance. So basically we have discussed in the previous slide, but basically this slide just want to tell you on how to compute it step by step. The first one, x minus your mu. Your first x is 0 and then you minus your mu, which is 2.1, and then the second step you have to put squared, so it's become 4.41, and the third step you have to multiply this with the probability of x, so you will get this value. So basically I will not recommend this because you have to spend a lot of time to compute each of them. So my recommendation or my suggestion is that just use the previous step or previous method to save a lot of your time. Okay, this is the second part of our chapter, binomial distribution. So if you want to apply binomial distribution, there are actually 4 requirements that you have to fulfill. The first one, there are only 2 possible outcomes and the outcomes are mutually exclusive. When we talk about outcomes, okay, so in the case of tossing a coin, so what is the outcome? You have head or tail, isn't it? So the outcome can be pass or fail. What else? The outcome can be male or female. So you cannot have something in between. You cannot have 3 outcomes, right? So when you want to apply binomial distribution, the outcomes are only 2. Okay, and they are actually mutually exclusive, means that you can only get one outcome out of these 2 possible outcome. Okay, the second characteristics or requirement, the number of trials is actually fixed and known. When you talk about tossing a coin previously, so you know that you will toss the coin 3 times. So it is known that you will toss 3 times or you will flip 3 times. Okay, it is known. The third one, the probability of a success is the same for each trial. Okay, so the probability is the same. Means that when you toss a coin, the probability of getting head the first time is 50%. Second time you toss a coin, the probability of getting head is still 50%, right? So the probability of success will not change. It will remain the same every time you toss a coin. The fourth one, each trial is independent of any other trials. It means that the first time you toss a coin, you will get what? Tail. The second time you toss a coin, maybe you will get tail. But this second tail, it is actually independent from the first one. Doesn't mean that you get the first tail, you should get the second is also tail. It is maybe you can get head as well. So the outcome is actually independent to each other. Okay? So you can look at the example given by this textbook at your own time. Okay? If you want to compute binomial probability distribution, we will use n to represent the number of trials, and we will use pi to represent the probability of success. Make sure that you do not confuse this pi with the pi symbol in math, because in math, this pi will give you the value of 3.1416. So our pi here will have different value compared to the pi in the math. Okay, so whatever you have in this green box, basically we have explained this in the previous slide. So these four things are actually refers to the requirement for the binomial probability distribution if you want to use it. Okay, how to compute a binomial probability distribution? So let's look at the formula. So P here is the probability of X. So X is something that you are interested in. For instance, when we talk about tossing a coin, so you are interested to see the head, right? So X here is your head, equals to small n. What is this n? N is just the number of trials. When you toss a coin, how many times? Perhaps 3 times. So that is the n. And you have a big C here. What is C? C is just a combination symbol. So it is actually available in your calculator. So how can you press C in your calculator? Basically, you have to press Shift and then the division symbol. So in your division symbol, you can see NCR there. So NCR is actually refers to your C. And then you have a small x here. X is the same with your previous x. And then you have pi. What is pi? Pi is just the probability of success into the power of x, the same x, multiply with 1 minus pi into the power of n minus x. Okay, so let's look at the example. There are actually 5 flights. So what is this 5? 5 is just the number of trials. Daily from Pittsburgh via US Airways into the Bradford Regional Airport. And then suppose the probability that any flight arrive late is 0.20. So when you talk about probability, it refers to your pi, okay, which is 0.2. Okay, what is the question? What is the probability that none of the flight are late today? So what is this none? None means 0. So this is your x. So how can you find the x? Normally x will be given in the question. So if you look at here, what is the probability that none? So after seeing this question, so you know that the value after your question is normally referring to your x. So write it here, x equals to 0. So after somehow writing down all these important points, you can just plug in into your formula. So what is this formula? Oh, so the formula is here. Okay, so you can just press your calculator. So your x is actually equal to 0 and n is given there, which is 5, and then you have c, just press it in your calculator, and then r. Okay, r here actually carries the same value with your x. So if let's say your x is equal to 0, your r should also equals to 0. So you put 0, pi is 0.2, and then 0, 1 minus pi, which is 0.2 into the power of, you have 5 minus 0. So after actually putting all these values, your calculator should give you exactly all this point, which is 0.3277. So you don't have to compute 5C0, which is equals to 1, and then 0.2 into the power of 0, which is equals to 1. You don't have to compute them one by one. So to save your time, just put all these numbers and then press it in your calculator. It should give you exactly this value. Okay, but in order to do that, your calculator should be in a higher level. For instance, for the case of my calculator, I use Casio, so you have to have at least 570 Casio. If the number is below than that, you cannot compute straight away. So you really have to compute one by one. So it may somehow slow you down to compute it. Okay, but don't worry, as long as you can somehow get the answer, that's good enough. Okay, let's look at the second question. What is the probability that exactly one of the flight is late? So what is this? This is your x, which is 1. So all items are the same. N equals to 5, pi equals to 0.2, and now your x is equals to 1. Okay, just replace 0 with 1, so you should get this value, 0.4096. So make sure that you have to practice it, because sometimes many students know how to apply the formula, but when they try to compute it in their calculator, they fail to get the answer. So try to practice with your calculator so that you are familiar with it. Okay, so in the previous slide, we have computed what is the probability that none of the flight arrive late. So you have computed it and you got 0.3277. We also have computed in the second question what is the probability that one flight arrive late. So you got 0.4096. You can compute all numbers. What is the probability that 2, 3, 4 or 5 flights arrive late? So you should get this value, and you can practice this at home. Okay, so what if the question asks you compute the mean for this probability? So do you still remember what is the formula for the mean? Mu equals to summations of x multiply with the probability of x. Okay, so what is your first x? 0 multiply with the probability of x, which is 0.3277. So this is the first item, plus the second item, 1 multiply with 0.4096, plus so on until the fifth item. So you should get the value of your mean equals to 1. Okay, so you have a very long computation or long calculation. So if let's say the question asks you compute the variance. So what is the formula for variance? Do you still remember? Summations of your x minus your mu, and then you have squared here, multiply with the probability of x. So how to compute it? So what is your first x? 0 minus mu, mu is 1, and then you have to put squared here, multiply with the probability of x. So 0.3277. So this is the first bracket, and then plus, because we are talking about summation, second item. What is the second item? 1 minus 1 squared multiply with the second probability, 0.4096, and this is the second bracket, plus everything until the fifth item. Okay, so this should give you 0.7997. So you will have such a very long calculation if you are asked to compute the mu as well as the variance. Okay, however, you have a good news here. The shortcut formulas are available for you, so you don't have to use the long formula to compute the mean and variance. So what is the shortcut one? So how to compute the mean? So you have mu equals to n, the number of trial, multiply with the pi, the probability of success. This is for the mean. And how about for the variance? So n multiply with pi multiply with 1 minus pi. So let's try to apply this formula. So remember your n, so let me write it here, n equals to 5 flight, and then your pi equals to 0.2. That's it. Okay, so how to apply the mu? Mu is actually n multiplied with pi. So 5 multiplied with 0.2. So you will get straight away equals to 1. How simple and how easy it is, right? And if you want to compute the variance, you know how long the formula for variance? But the formula here is n multiplied with pi multiplied with 1 minus pi. So you should get straight away 0.80. So this actually can save a lot of your time. So try to be smart. If you are asked to compute the mean, and if you are asked to compute the variance, use the shortcut formulas. Okay? This is another example of binomial probability distribution, and you can try to do it at home by computing the probability distribution. Try to compute the mean and variance using the shortcut formula and so on. So in this case, I want to tell you, if let's say you have this kind of question, how do you know that you have to apply binomial probability distribution formula? Do you still remember we have like a few requirements if you want to use the formula of binomial? So let's look at this question. In the source with 5%, so what is this 5%? This is your pi. Remember, probability is your pi. 5% of all cell phone calls are dropped. Okay, so next, what is the probability that out of 6 randomly selected call, none was dropped, exactly 1 was dropped, and so on? Okay, so let's see whether all this information fulfills our binomial probability condition. So the first condition, so what is the first condition? You have two possible outcome. You only have two possible outcome. Remember, we have head or tail when we toss a coin. In this case, your outcome is whether the phone call is dropped or not dropped. Okay, so you have two outcomes. The second one, fixed number of trial. Okay, remember when we toss a coin, we toss it 3 times. In this case, you have 6 randomly selected calls. So you have fixed number of calls, which is 6 calls. And the third one, what is the third one? A constant what? Probability of success. So in this case, when you call, so there is a probability of 50% of the call is dropped, and another 50% of the call, maybe they will answer your call. So you can see that there is a constant probability of success. And the fourth one, what is the fourth one? Trials are independent. Let me write it here. Trials are independent. So what does it mean? So when you first call, maybe the call is dropped, and the first is dropped. The second call, maybe it is also dropped. Doesn't mean that the second call follow the first call. So your outcome is independent to each other. Okay, so basically in this question you have fulfilled all these 4 requirements of binomial probability distribution. So you can proceed using the formula of binomial probability distribution. Okay, so remember, once you receive the question, you have to check whether it fulfills all these 4 requirements. Then you can apply the formula. Cumulative binomial probability distribution. So what is cumulative? Let's say we talk about your CGPA. What is CGPA? Cumulative grade point average. So what is cumulative? It refers to the combinations or the summations of all your grades in the whole semesters, right? So when we talk about cumulative here, it is also referring to the total or summations of all. So let's look at the example. A study by the Departments of Transportation concluded that 76.2%. What is this 76? This is your pi. Remember, probability is your pi. So maybe it's better to write it here. Pi equals to what? 0.762. Okay, because you have to convert it into a percentage or into a decimal point. Okay, concluded that 76.2% of the front seat occupants wore seat belts. It means that both occupants of the front seat were using their seat belt. Suppose we decide to compare that information with the current usage. So we have selected a samples of 12 vehicles. What is this 12? So you have n equals to 12. So you are waiting for x. So as I told you, x is normally given in the question. So let's read the question. What is the probability that the front seat occupants in exactly 7? So this is your 7. This is your x already. Out of 12 vehicles are wearing seatbelts. So you know that you have all these three information. You can just plug it into the formula of your probability distribution or your binomial probability distribution. Okay, so the question for cumulative is actually number 2. So let's look at the question. What is the probability that at least 7 of the 12 front seat occupants are wearing seatbelt? So at least is actually referring to your cumulative. Okay, what do you understand by the words at least? At least means the minimum number should start with 7. So at least 7, you have 7, 8, 9, 10, 11, and 12. So at least you start with the number of 7 until the last one, which is 12. So when you have this kind of question, it asks you what is the probability that at least 7 of the front seat occupants are wearing seatbelt. So you have to compute all this probability. So you have to compute the probability of x equals to 7, and then you have to plus, because we are talking about cumulative. So you have to have summations of many things. So plus probability of x equals to 8, and you have to stop until probability of x equals to 12. So you have to compute all this probability and sum them all. You should get the value of 0.9562. Okay? If binomial requirement cannot be met, we can use either hypergeometrics or Poisson distribution. Let's recall, one of the requirements to use binomial distribution is that the probability of success, or we can say our pi, should remain the same from trial to trial. So let's take the examples of tossing a coin. So the first time you toss a coin, you will get 50% of having the head. The second time you toss the coin, the probability of getting the head is still 50%. So regardless of how many times you toss the coin, the probability of getting the head or tail will remain 50%. So if let's say you violate this assumption, you cannot use binomial formula anymore. So you have to use hypergeometrics. What is it? So it says that when you sample from a relatively small population without replacement. So what does it mean? I will explain to you soon. So you have to use hypergeometric. So let's take this classical example. For instance, you have this ball, not really ball, you have a box. So inside this box, you have 10 balls. Okay, so your population is very small. You only have 10 balls. So inside this box, you have two colors. One is red, another one is white. But you are interested to pick the red color. However, you only have one red ball and the remaining 9 is the white ball. Okay. So let's assume you have one person. This person picked the ball inside this box by closing his or her eyes. So perhaps he will get, let's assume that he will get one white ball. Okay. So if let's say he took it without putting it back, so the number of the population will become smaller. So we can say that without replacement means he took the ball without putting it back. Okay, so when he didn't put it back, the number of your population is getting smaller. Okay, so for the second person, how many numbers now? Your population become 9, and now you have one red ball and remaining 8 white ball. So the chance of the second person to get this red ball is higher, right? Because the number of population is getting smaller and smaller, and the chances is even higher for perhaps the 9th person to pick the ball, right? Okay, so we can say here, we can see that the pi is changing. The probability of success is changing. Okay, so in this case, you have to use hypergeometric. So let's look at the characteristics of your hypergeometric. So the first characteristics and the second one are actually the same with the binomial distribution. Okay, so let's look at it. An outcome of each trials of an experiment is classified into one or two mutually exclusive category. You can have red ball and you can have white ball. Okay. Second, the random variable is the number of success in a fixed number of trials, which is the same with the binomial distribution. Number 3, this is something different. The trials are not independent. Every time someone pick the ball, the number of the population is changing. First time you have 10 ball, second time you have 9 ball, and it will keep reducing until how many people pick the ball. Okay, and the more people pick the ball, the higher the chances, or we can say the pie is changing, the higher the chances of success or getting the red ball. And the last one, we assume that we sample from a finite population. It means that from a small population without replacement, means that you didn't put the ball back into the box. And this is another requirement or characteristic. The sample over or divide with the population, you should get bigger than 0.05. This is the technical characteristics of hypergeometric. So the probability of a success changes for each trial. You know that the pie will keep changing because your total population will also change. Okay? So let's look at the examples of hypergeometric distribution. So you have probability of x. What is this x? X is the number of success in the sample equals to S. S is the number of success in the population. You have a combinations of C, and then you have capital N here. Capital N refers to your population, and then you have small n. Small n refers to your sample. Okay, so Play Times Toys Incorporation employs 50 people in the assembly department. So you have 50 people here. So you can say that your capital N, your population is 50. Such a very small population. 40 of the employees belong to a union and 10 do not. Okay, so you have 40 people belong to the union and 10 do not. Okay, so it is easy for you to draw a tree diagram so that you can see everything clearly. And what's next? So 5 employees are selected at random. So what is this 5? 5 is your sample because you selected them at random. So sample is your small n. Okay? Big N or capital N is your population while small n is your sample. And how to find your x? So normally, as I told you in the previous slide, x will be given in the question. So what is the question? What is the probability that 4 of the 5? So you have 4 here. So your x is actually 4. Okay, so what is missing here? You have capital N, you have small n, you have x. So you also need to find the s. What is x? S is the number of success in the population. So what do you want to know? You want to know what is the probability that 4 of the 5 belong to a union? So you are interested in the union. So you can see here 40 people belong to the union. So 40 is your S. Okay. Now after having all this information, it is easy for you to plug in all this information in the formula. Okay. So you should be able to get the value of 0.431. Try to practice with your calculator. Okay. Basically, we have computed the value of 4 out of 5 members belong to a union. So this is the answer that we get in the previous slide. So you can also compute the other probability. And you know that summations of all this probability will get you equals to 1. And you call it exhaustive. The last types of distribution is called as Poisson probability distribution. So Poisson is a limiting form of binomial distribution when the probability of a success is very small but the n, the number of population, is very large. Okay, so let me give you an example. For instance, the probability of success, let's assume that the example is accident, getting into accidents. The probability of having accident is very small. However, the n is very large. What is n here? The number of cars on the roads are a lot. In a day, you have thousands of cars on the road, but the probability of having accidents, perhaps 1 or 2 accidents, it is very small. So this is one example of Poisson distribution. Another example, when you are actually inserting a data, you key in some data. The probability of making mistake, perhaps very small, but the data that you key in, perhaps thousands of data, right? So this is the second examples of Poisson. Okay, so let's look at the slide. So Poisson describes the number of time some event occurs during a specified interval. So when you talk about Poisson, you are talking about interval. So what is this interval? Interval can be time. Time here means period. When you talk about year, when you talk about duration, okay? When you talk about day, that is time. Distance, area or volumes. So there are two assumptions if you want to apply this Poisson distribution. The first assumption is the probability is proportional to the length of the interval. So what does it mean? It means that the longer the interval is, the larger the probability. Okay. The second one, the intervals are independent with each other. It means that the number of occurrences in the interval does not affect the other interval. For instance, we talk about accident. If let's say this year you have 100 cases of accidents, next year maybe you will get also 100 accidents or 300 accidents. So the number of accidents happen this year has nothing to do with the number of accidents happen next year. So we can say that the interval, the year, are independent to each other. Okay, so you can also apply this Poisson. If let's say you want to describe the distributions of error in data entry, you can also use Poisson when you want to describe the number of accidents during a few months period. Okay, this is just some examples of using Poisson. I have explained the characteristics or the requirements to use Poisson distribution in the previous slide. So this green box that you see here are actually explaining the same thing. So let's go straight to the formula of Poisson distribution. So Px or probability of x equals to the mu into the power of x. So what is this x? X is just the number of success and then multiply with e. So this e is actually available in your calculator into the power of minus mu over x with these exclamation marks. And this exclamation marks is actually available in your calculator as well. Okay, if you are asked to compute the means of Poisson distribution, the formula is given here. Mu equals to n multiplied with the pi. So this formula is very similar with the binomial distribution. However, if let's say the question asks you to compute the variance, so what is the formula? The formula for variance of Poisson is also the same with the means of Poisson. So if let's say you are asked to compute the mean or variance, you will use the same formula, which is n multiplied with pi. Okay, remember that. This is the examples of Poisson distribution. Budget Airlines is a seasonal airline. So seasonal is a keyword to tell you that you have to use Poisson distribution because it is referring to the intervals or periods. Okay, so these airlines operate flights from South Carolina to various cities in the Northeast. Recently, Budget has been concerned about the number of lost bags, and Poston from the analytic department was asked to study the issue. She randomly selected samples of 500 flights and found that a total of 20 bags were lost on the sample flight. Okay, so if let's say you are asked to compute the mean number of bag loss, how to find the mean? So what is the formula to compute the mean? Mean equals to what? N multiplied with pi. So can you see any pi here? What is pi? Pi normally refers to probability. So you cannot see any probability or decimal number. So how to find the mean? So do you still remember the formula of mean that you have learned in the previous chapter? What is the formula of mean? Summations of x over n. So what is this x? X is your observation, n is the total number. So x is what? 20 bags that were lost, right? So you have 20 over how many in n? 500. So you should get the value of 0.04. So this is your mean or your mu. So now you have your mu. So how to compute it? So let's look at the question. The probability that, so basically what is the probability that no bags are lost is found. So what is your x here? You know that x should always be given in the question. So no bags means x equals to 0 here. So for Poisson distribution, you only need two items, which is x and mu. So you can just plug in all these two items in the formula. You should be able to get this value, 0.96 or 8. Okay, so this is very simple. And the next one. So this next question refers to the cumulative Poisson distribution. So for your information, you can use cumulative formula. Basically, it just refers to many items. You can use cumulative in binomial distribution, you can use cumulative in hypergeometric, you can also use cumulative in Poisson. So here, calculate the probability that one or more bags is lost. So how many bags do you have? You have 500 bags. So if let's say the question asks you to compute one or more, so you have to compute the probability of x, which is bag loss, equals to 1, plus x equals to 2, plus until x equals to 500. Can you compute this? It is too hard. So you have a simplest way or easy way to do this. Okay, so you can write probability of x, which is equals to 1 or more, equals to 1 minus probability of 0. So you know that the total probability is 1 and probability range from 0 to 1. So you can just take 1, which is the total probability, minus the probability of 0. So you will get the value of 0.392. It means that once you take the total value, which is 1 minus the probability of 0, it has covered the value of lost bag from 1 until 500. So you can also do that. So this question can be changed into calculate the probability that at least one bag is lost. So if let's say you can see at least means that starting from 1 until 500. So you should know how to answer this kind of question. This is another example of Poisson distribution. You can actually do this at home, okay?